All right. Okay. You have your practice guide out. We're going to go through the second half today. I believe we left off at number 9 yesterday, correct? Number 9?
Yes, all.
Okay, so let's go through the rest. We'll turn off the lights, we'll get going here. Yeah, please and thank you.
Now I can't see.
Jordan, I told Jordan.
Oh, he's gonna fire up the
Hi, Jordan. I thought I got my braces out.
When you tell me that, you think I'm gonna believe
He
it?
said cool. I thought you didn't believe me.
That's a large pile.
Jordan, what do you think?
You never asked me that. I'm sorry you didn't.
Alright.
That's what all the time.
Okay, so practice guide. Hey, real quick, problem number 1. We did this one just the other day. Let me put the lights in here. That's really okay. All right. So number 1, you had to plug in your value, simplify it all the way down to a single digit, like a constant. Make sure that on test day you plug in the number and then you actually simplify it. I had somebody a couple of years ago. I think it was like 2 or 3 for pre-calc. They like foiled that whole thing out, like to the power of 3 term, right? Using their, their Pascal's triangle. Then, they did all the math, they simplified all their terms, and then they tried to plug in the 9 after that. That's really difficult. Like, just plug in the 9 first. It makes small numbers, right?
Did they get the right answer?
Yeah, but it took them they're like, Ward, you didn't give me nearly enough space. Like, because they use the whole side going all the way down to do it. It was meant to be like a 3 line problem by just plugging the 9 and then solving. 2 and 3, make sure you know the difference between intersection and union. We did that one the other day. Just simplify this number 4. Remember, you're not solving. There's no equal sign, no equal sign. Just simplify it down, until you get to your number, to your variables and numbers, right? 5, plug it in, or not plug it in, but you can type that in your calculator if you need to know the powers. I would just say do it by hand because the number should be relatively small. But you do need to know, if I put a power of 8 there, you need to know how to type in your calculator. Because I might give you a big one just to see if you know the actual buttons in there. And remember, on test day, I don't answer how do I type this in here? That's not a question I answer. So you gotta know how to do it today if you have a question on that. 6, multiply them together. Just be prepared on number 6, hint, hint. I could give you that same style problem, but I put powers on those parentheses. So you have to do the powers first to make those things bigger, and then multiply them together. Hint, hint. 7, same thing, distribute the power, simplify it. It'll be something like that. 8 and 9, these are the ones we finished with yesterday. I warned you of this, these are scientific notation and you had to give me the number for them, the digit. What I could possibly do here on this, I could definitely give you just a number and I want you to give me the scientific notation, go backwards. So be cautious of that. Does that make sense? That's where you left off. All right, today. Goal is to pick up at number 10, because I said we had a bunch of radicals and I didn't want to do those yesterday. We're going to pick up with radicals and we're going to basically just go through the rest of this thing. I think there's 19 problems here. So we're just going to cruise through the rest. Since we're done, we're done. You have homework due, what is that, tomorrow? You have homework due tomorrow, page 65, if you haven't been working on that yet. This test is tomorrow. Remember that. You have a test in here tomorrow. So when you walk in, the test will be, or the desk will be in way different order than you have today. I basically spread them out very big. I'll use all the space in here. I'm gonna have chairs everywhere. Just come and sit down, turn in your work into whatever basket you want to turn it in, and then we're gonna get ready to go. Okay, practice guide, this thing you have in your hands has to be turned in tomorrow. It's one of the things, we're doing it in class together, so you should get easy points for it. Okay? Late work, get it turned in by tomorrow, because midterms are tomorrow, or Monday, so I want stuff so I can grade it. Okay, all right, here we go. Number 10, to simplify it, I would just multiply these together first. That's just what I would do, because you can multiply any type of radical together as long as they're the same type of radical, not a cube root times a square root. I could show you how to do that later. But on this problem, I would multiply these together, and what you get when you multiply 10 times 8, you get 80, and the x's you multiply them together, and that's x squared. You can do that inside the radical. Now that we have that, now we can take now we can simplify this thing down. I don't mind which form of simplification you use for your radicals. I don't care if you're that product rule person, that's the way I've kind of taught most people, where you break down 80 to be 8 times 10, and then you break down that to be 2 times 4, and 2 times 5, and then 2 times 2 times 2 is the 4, times 2 times 5. And then you have the x's in the back, right? That's just breaking down the numbers as far as you can. And then what type of radical am I using here? What's my index number?
2.
2, right? The index number on the outside is a 2 because they don't have it printed. If it's printed in there, it'll be pretty obvious. It'll either be sitting here or here. That's what it'll be sitting. And you'll notice it. Microsoft Word kind of puts it in a different spot. But you'll know your index number, and I'll kind of warn you of that too. But we're looking for pairs. That's what that index number is telling me. I'm looking for 2 numbers that match. We'll have a pair of 2s, a pair of 2s, and a pair of x's. So you'll kick them out. So there'll be a 2, another 2, and an x on the outside. Because remember, every time you always kick one of the pairs out, one of the numbers. And then what's left on the inside is a 5. That's what I'm looking for. Does that make sense? Now you can finish the rest. Please just multiply the 2's together. But does that make sense how to simplify? They can be anything. As long as they're the same type of radical, you can multiply them together and simplify from there. Just be kind of ready to go on that. I'm not going to be I'm not going to be checking for if you're using absolute value bars on the variables, because I didn't check that for your homework. I'm basically just kind of looking at how are you actually breaking those things down. All right, let's move on to the next one. So now we're on to number 11. Computer over here. All right, number 11. What I would do on these first, I would definitely try to divide if I can. If you cannot divide those two things because they're both in radicals, then you'll have to do that thing where you have to multiply the bottom to try to get the radical to simplify. So you have to break down the bottom, look at what's the minimum things I need to multiply on to make sure that I can circle pairs or triplets and kick them out. On this one, I can divide these. That's called a quotient rule. You can actually just divide right away because they're both in a radical. So 24 divided by 3 is an 8, so there would be an 8 left on the top. X to the 4th divided by x, x to the 3rd. So it looks like I don't even have a fraction. I can actually just divide those right away. That's kind of nice. If you didn't do it that way, that's fine. You'll do it by a different way, but it'll simplify later. Maybe you multiply both the bottoms by root 3 of x and the top by root 3 of x. That's fine. But you'll simplify it later to be the same answer I have. And then you'll break these down. So 8 is 2 times 2 times 2. On the x is x times x times x. And now what I'm looking for is pairs, because I have an index number of 2 still. Again, the index number is telling me everything. If you know your index number, if you know your index number, that tells you how many pairs you're looking for, or triplets or quadruplets. I have a pair, my index number is 2, so I'm looking for pairs. I have pairs of 2's and x's. So those go on the outsides, and it looks like I'm left with a 2 and an x on the inside, because I didn't circle them. Remember, if you're circling triplets, you kick one out and the rest of them are gone from that triplet. Always just one goes to the outside and the rest of them just kind of disappear. Okay, questions at all about 11 or the types of problems that could sit there? Because if that doesn't divide out evenly, then you have to figure out what you have to multiply by to make a triplet or a pair on the bottom so that it simplifies. It's called rationalizing. Okay, we're good? Moving on, let's go to number 12. Okay, we're going to subtract and add if possible. So this is one where you have to actually break down radicals to see if they'll actually turn out to be the same. Because if they don't turn out to be the same radical, you can't actually add or subtract them. They have to be the exact same radical in the back behind it. So if I'm starting this problem, what I'll do on the 63 is break that down to be 9 times 7, which is 3 times 3 times 7 times x. There's the first parenthesis. The back one is 2 times 2 times 7 times x. That's 28 broken down. That's 4 times 7. It looks like I do have pairs, so I can kick them out, because my index number is 2's here. So if I kick those out, I'm left with a 3 root 7x. Kick out a pair, that's 2 root 7x. So it's lucky that I had this, pairs in there. And now, can I subtract from here? Yeah, so now you can subtract. And when you add or subtract radicals, you actually just add or subtract the number out front. Everything else behind the number actually stays the same. So if there's variables or whatnot behind these numbers, these leading coefficients, then those will just stay the same. But they have to have the same letters. If the letters are not matching, you can't actually add or subtract them. That does happen sometimes. But again, you'll actually subtract and you're gonna get 1 root 7x. Right? You don't actually have to write the 1, I just put it in there to show you what I'm subtracting. Okay, questions at all about number 12? Okay, 13, basically the exact same problem. It looks more complicated, it's the same problem. You're gonna break it down, write your little pairs, circle and kick them out, see if they work out to be the same, so that you can either add or subtract. You're actually seeing the Microsoft Word way of doing cube roots. You can see how big that little index number is if they ever have to print it in there. So you're kind of seeing it, so it's cube roots. I'm looking for pairs, or triplets I mean. So 24, and it's 2 times 2 times 2 times 3, times x times y times y times y. And I'm trying to do a cube root. And again, if you drop the cube root symbol, like the 3 off the radical, I do count it wrong. So be careful of that. 81 with a y up front. 81 is 3 times 3 times 3 times 3. And then there's an x. 9 times 9, yeah. And now I'll kick out pairs, triplets, if I have any, and then see if the radicals actually turn out to be the same. And then I can subtract. I'm going to leave that one for you. I think I broke it down as far as you probably need it to be, so you can kind of see how to do it. Questions, comments about how to do it? I think your final answer is negative, I believe, when you actually subtract across. So that's a little hint for you. Okay, we're good? All right, move to the next one. 14, we have to rationalize. Rationalizing means that you need to get rid of the radical off the bottom and it doesn't just divide off. Like on this one, there's actually 2 different radicals on the bottom. So I'll have to try to simplify this here in a second. Okay, so what do I need to multiply by on this fraction so that I get rid of the radical off the bottom? What's the term called? You have to multiply by. It starts with the letter C.
Conjugate.
Conjugate. So the conjugate is taking the bottom and just changing the sign. That's all a conjugate is. It's taking whatever's on the bottom and flipping it around. So here's what I'm going to multiply by, top and bottom. Because multiplying by this thing is multiplying by 1, because those actually divide off to make 1. So if you multiply by 1, the answer's still the same. So it's just, it looks like I'm changing the whole look of the problem, even though it's the same value on a calculator. It just makes it look a lot easier, and it's easier to type back once you get it simplified. Okay, so on the top, when you have this, since the top is just a single monomial, so it's actually a constant, you can just distribute that. So I'm going to distribute the 11 to everything here. That's what we've already previously done. So that's 11 root 7 plus 11 root 3. Okay, there's that. And notice I can't actually multiply that. Don't write 77 and 33, don't do that. Because if it's a number times radicals, they don't actually multiply. Now on the bottom, this is where you have to do FOIL. You have to go first, outer, inner, last. So the first terms are root 49, because 7 times 7, and I can actually multiply those because they're in radicals. The outer is positive root 21. The middle is negative root 21. Those cancel. But again, this is what you get if you actually multiply them first, outer, inner, last. You get this. So those middle terms will cancel, because outer, inner. And then the last term is a negative root 9. Negative root 9. So the middle terms drop, and then you can simplify from there. These actually turn out to be nice constant numbers. These are actually nice digits. And these will cancel. And whatever this bottom number turns into, you just have the top over the bottom number. That's what I want. I want to make sure that there's no radicals left on the bottom. That's what should happen if you did it correctly. Questions on 14. I'm going to let you finish the rest of that. I think I got it to the point where you can just kind of do 2 more steps. And have done, or 1 more step maybe, you already did it. All right, let's go to 15. 15 has a lot of directions, and this is another one that people kind of go too far on my previous tests. It's kind of like that problem number 1 where people like go way overboard because they read the problem wrong, or they just didn't even see what it was asking for. Okay, so you're going to do the indicated operations. Fine, that's what the book said. You're going to, write the resulting polynomial, the final polynomial, and it has to be in what they call standard form, which is descending order. of x's, by the way. And then you have to also state the degree. That's the part people get wrong. They forget they have to state the degree of their problem. Okay, I'll give you a little bit of time if you're actually attempting this. Let me start and stop the camera here. Okay. So, I think my camera moved on me. Okay, so on number 15, what's my indicated operations between these two, or these three parentheses? What are we doing? What's the overall thing we're trying to do here? The overall operations. Say it. Adding and subtracting. We're not multiplying. Did everyone hear that? You're not multiplying. I had somebody, it was the same person actually, 3 years ago, multiplied all of these together. There's a lot of terms going across because all they thought you had to do is distribute the sign and then multiply. No, you're adding and subtracting. It's meant to be like a two-step problem. So you're going to be adding and subtracting like terms. This is what I would do if I was starting this problem and this was on my, if I was taking this test. I'd write it like this without the parentheses. I know that seems silly, but it's nice to make sure that I have all the signs written out correctly and I'm not trying to do a bunch of stuff in my head. I go, I'm going to distribute and I'm going to try to add these like terms in my head. I would actually write down every step. I would rearrange this thing to move like all the x squared terms next to each other. So like put the 5x squared, that positive 2x squared and the negative x squared. I'll move those next to each other so I can actually see what math I'm doing there. That's -1, by the way. And then I'll move the x's next to each other and the numbers. Okay. Does that make sense? Like how I want you to do it? I know most of you can probably do this in your head really quickly. I understand that. But I want to make sure that you show some form of work because nothing's worse than somebody getting a wrong answer. And I don't know how they did it because they did everything in their head and it's not right and I don't know how they did it in the first place. So I move everything together and then you guys can figure it out from there. All right, so now combine these, combine the x's, combine the x squares down. I try to color code as best I could. Once you have everything written, what's the last thing you have to make sure that you answer? Degree. What degree is this thing? Second degree. So you better write degree 2 or second degree, I don't care. It better be somewhere on your paper. The reason why it's a second degree is because the x squared terms don't drop out. If they went away, like maybe they cancel each other out perfectly fine, then your degree is a 1 degree, like a first degree. It's just an x. You're not solving, don't throw in an equal sign and try to solve this thing. We're not solving, we're just doing simple operations. It's meant to be easy points, lots of stuff. All right, 16, you have to FOIL this out. First, outer, inner, last, or distribute twice. I don't know how you want to think of it. There's two ways to kind of process this one, but I would just write down, the 2x times everything in the back. Then after that's all done, then I would go after, the -3 and distribute that to the back. How many items should I have written out before I start simplifying? 6. Because the first parenthesis has 2, the back parenthesis has 3. When you take 2 times 3, you should have 6 items across your paper, and then you'll simplify. That's all you're doing. You just simplify. You're not solving, you're not doing anything. If this problem turns out to be something with powers, like it has a power of 2, it has a power of 3, guess what you have to do? Pascal's triangle. If it's a power of 2 or 3. So I could ask you to multiply things together, I don't want you to FOIL. I want you to actually. So that's a hint. I could ask for one of those. Okay, are we good? Perfect. 17 and 18. And 19. Okay, these problems say factor. So you'd have to factor completely as far as you can without stopping. Don't just stop because it looks good. You have to make sure you did every step. So we always check common factors first. If that's not there, then you would do trinomial if that's possible, or you do difference of squares, cube rule, and then grouping. And I go in that order. Okay, by looking at this problem, it looks like the top one's probably a cube rule. The second one's a grouping method, because I can't add anything, there's 4 items across, that's kind of obvious. And then number 19 looks like it's a common factor and probably a trinomial, or maybe even further than that. Okay, is there anyone specifically you'd like to see to make sure you know how to do it?
Top one.
Top one? Let's do the cube rule. Okay, top one. All right, if we do a cube rule, remember it's small parenthesis, and then it's a big parenthesis. That's the rule, right? Small, big, binomial, trinomial. The symbol that's on your problem goes in the front. It's always the front parenthesis, whatever it is, plus, minus, whatever it is. Then the next one's the opposite of it, and the plus is always in the back. I think it's soap. Same, opposite, always positive. Now that you have that, now to get the first parenthesis, because the first parenthesis is the most important, you just take the cube roots of these. So I'm going to actually take the cube root of this and the cube root of 125, because we're doing the cube rule, and that's what goes here and here. That's how I figure out those numbers out. Well, the cube root of 8x cubed is 2x. The cube root of 125 is a 5. So now that I know that, now this problem's a lot easier because now I use those two numbers to get the back parenthesis. All right, questions on how I found the first parenthesis. Now to find the back. These items, the front and back part, are just taking these items here and just squaring them, put a power 2 on. So 2x to the power 2 is a 4x squared. 5 to the power 2 is a 25, that goes here. So those are easy, you square. But the middle term, you just made from these two multiplied together. So that's a 10x. There's your answer, that's factored completely. You don't need to multiply it back together. The only people that I know like to multiply back is if they're checking their answer, see if they did it right. But that's the answer I'm looking for, you know, factor the part. When you're multiplying to get this middle term, in class what we talked about to get this one, you ignore the signs. So even though there might be a negative here, you ignore it and you just multiply the two digits together, or the variables together, whatever is sitting there. Ignore the signs, because we already knew the signs before we started. We already knew it was plus, minus, positive. If you throw another sign, it'll mess it all up. Okay, questions at all? Okay, I'm gonna let you have the rest of time today. You have about 15, 16 minutes, something like that. You can work on this. You can work on your page 65. If you have missing work, which I don't think any of you did, I haven't told you, you could be working on, you know, other things for other classes. Test is tomorrow, but just be ready to go. It shouldn't be that difficult, but definitely say if you have questions, don't be afraid to come in. Remember on test day, when we walk in here for testing, like right after that bell goes off, I don't answer questions. We turn in stuff and we're going, so you have enough time to actually work on it. And calculators, make sure you have them, because I have 10. I'm hoping that I'll have 10 by the start of tomorrow. All right. The rest of the time's yours.
That sound like gray.